Hi everyone, welcome to this video on Bitcoin, making change. Many Bitcoin transactions will include outputs that reference both an address for the new owner and an address of the current owner, called the change address. This is because the transaction inputs, like currency notes, cannot be divided. If you purchase $5 item in a store but use a $20 bill to pay for the item, you receive $15 in change. The same concept applies with Bitcoin transaction inputs. If you purchase an item that costs 5 Bitcoin but only a 20 Bitcoin to use, you would send one output of 5 Bitcoin to the store owner and one output of 15 Bitcoin back to yourself as change, less any applicable transaction fee. Importantly, the change address does not have to be the same address as that of the input. For privacy reasons, is often a new address for the owner's wallet. Different wallets may use different strategies when aggregating inputs to make a payment requested by the user. They might aggregate many small inputs or use one that is equal to or larger than the desired payment. Unless the wallet can aggregate inputs in such a way to exactly match the desired payments plus transaction fee, the wallet will need to generate some change. This is very similar to how people handle cash. If you always use the largest bill in your pocket, you will end up with a pocket of loose change. If you only use the loose change, you'll always have only big bills. People subconsciously find a balance between these two extremes, and Bitcoin wallet developers strive to program this balance. In summary, transaction move value from transaction inputs to transaction outputs. An input is a reference to a previous transaction's output, showing where value is coming from. A transaction output directs a specific value to a new owner's Bitcoin address and can include a change output back to the original owner. Outputs from one transaction can be stored as inputs in a new transaction, thus creating a chain of ownership as a value is moved from one owner to owner. See figure 2.4. So here's see figure 2.4, and here we have our different wallet addresses. Common transaction forms. The most common form of transaction is a simple payment from one address to another, which often includes some change returned to the original owner. This type of transaction has one input and two outputs, as shown in figure 2.5. Another common form of transaction is one that aggregates several inputs into a single output. See figure 2.6. This represents the real-world equivalent of exchanging a pile of coins and currency notes for a single larger note. Transactions like these are sometimes generated by wallet applications to clean up lots of smaller amounts that were received as change for payments. Figure 2.6. Transacting, aggregating funds. Finally, another transaction form that is often seen on the Bitcoin ledger is a transaction that distributes one input to multiple outputs, representing multiple recipients. See figure 2.7. This type of transaction is sometimes used by commercial entities to distribute funds, such as when processing payroll payments to multiple employees. Constructing a transaction wallet. Alice's wallet application contains all the logic for selecting appropriate inputs and outputs to build a transaction to Alice's specification. Alice only needs to specify the destination and the amount, and the rest happens in the wallet application, without seeing her details. Importantly, a wallet application can construct transactions even if it is completely offline, like writing a check at home and later sending it to the bank in an envelope. The transaction does not need to be constructed and signed while connected to the Bitcoin network. Getting the right inputs. Alice's wallet application will first have to find inputs that can pay for the amount she wants to send to Bob. Most wallets keep track of all the available outputs belonging to the address in the wallet. Therefore, Alice's wallet must contain a copy of the transaction output from Joe's transaction, which was created in the exchange. See Getting Your First Bitcoin, page 10. A Bitcoin wallet application that runs as a full node client actually contains a copy of every unspent output from every transaction in the blockchain. This allows a wallet to construct transaction inputs as well as quickly verify incoming transactions as having correct inputs. However, because a full node client takes up a lot of disk space, most user wallets run lightweight clients that track only the user's own unspent outputs. If the wallet application does not maintain a copy of unspent transaction outputs, it can query the Bitcoin network to retrieve the information using a variety of APIs available by different providers, or by asking a full node using an application programming interface API called example 2 shows an API request constructed as a HTTP GET command specified to a specific URL. This URL will return all the unspent transaction outputs from an address, giving any application the information it needs to construct transaction inputs for spending. We use a simple command line HTTP client C URL to retrieve a response. Example 2.2 look up all unspent output from Alice's Bitcoin address. So C URL blockchain info unspent active 1C DID 9K F capital A lowercase a TW CZ capital B capital W capital B TTQ CW capital XY capital C QV capital K H 7 capital F capital K. Unspent outputs tax hash TX hash 186 F9 F99 8A5 23283 DD 734 D 2804 FE 65 FA 3779 text TX output N0 script 76A 9147 F9B 1A 7F68 D60 C536 C2F D8 AA53 A8F3 CC025 A triple 8 AC value 1000000 value hex 09989680 confirmations equals 0. The response in example 2.2 shows one unspent output, one that has not been redeemed yet under the ownership of Alice's address. 1C DID 9 KFA AATWC ZBWBTT QCW XYC PVK 87 FK. The response includes the reference to the transaction in which this unspent output is contained, the payment from Joe and its value in Satoshis at 10 million, equivalent to 0.10 Bitcoin. With this information, Alice's wallet application construct a transaction to transfer the value to new owner address. As you can see, Alice's wallet contains enough Bitcoin in a single unspent output to pay for the cup of coffee. Had this not been the case, Alice's wallet application might have to rummage through a pile of smaller unspent outputs, like picking coins from a purse, until it could find enough to pay for the coffee. In both cases, there might be a need to get some change back, which we will see in the next section as the wallet application creates the transaction output payments. So I'm going to leave it here today for this video. If you like listening, please consider like, share and subscribing. Thank you.